Okay, hey everybody, we're live. I'm live with Cameron Ward. Did I say it right?
That's it.
Okay, what's up, Cameron?
How are you? Doing good.
So we have been going for an hour and a half trying to get things going right, and then you hit the start button. So Cameron, you have been working on a let's see what have you been working on your
The cosmic fabric model.
cosmic fabric model? And that's a continuation of uh, Ticho
hmm
work with Mark Horstmeyer at Liberty.
It was Tico's thesis, his PhD thesis at Mississippi State. And since then, Horstmeyer has moved from Mississippi State to Liberty, which is where
Gotcha,
I'm at now.
gotcha. Okay, awesome. And Cameron, it was at the ICC, this last ICC that we met in person, right?
hmm
And
Yep.
and then we were going to do a recording possibly. We got to hit Cameron and I got to hang out, and a lot of other good people at the CRS conference that we just did at the ARC. This what, a week, was that 1 week ago, week and a half,
Yeah. Yeah, that was a week ago.
right? But some of those things didn't work out. We're like, okay, we'll just push this off, and this is my
We had
first.
too many good conversations that
Yeah,
came up, right?
yeah, too many good conversations. And I really appreciate you coming on, and I hope we can maybe do a couple of these. Or a few of these or whatever. Cameron and I were just talking about. There's a lot of content here. I have been for half my life very invested and interested in what Scripture has to say about day two of creation, the Rakia. What is that and stuff? And so Russ Humphreys' work, Starlight and Time, has always been, one of big love of mine, research interests and stuff. Although for me, it's been more on, the biblical theological side. But then it's a real treat to get, to learn from these guys who are, um, looking at this great mysterious thing. And we should right here give thanks to our God who made the heavens and the earth, right? He made the
Yeah.
heavens. And just to step back here, before we get technical, well, God made the heavens and the earth. And on this is part of the heavens is what is space itself? What is
Yeah.
space time? What is this? I wish I had the scripture ready, but somewhere in Isaiah 40 something, he says he made the heavens. He made it to be inhabited, Lashevet. And without him making the heavens, there's no, you can't live here. So I'm not saying the
Yeah.
Rakia is exactly, the same thing as this possible idea of space is a thing. That's a mysterious and a very big topic. Um, Nonetheless, just to jump into this, I guess we're gonna figure out how to just pick Cameron's mind and see what he's been doing with this model. So Cameron, yeah, what got you into this first? How did how'd you get involved in these matters and stuff?
Oh man. Well, I've always grown up just being interested in creation apologetics and whatnot. When I was in high school, I didn't know anything about any of this. I was reading scripture for myself, read the genealogies in Genesis and saw the ages, kind of figured out that the earth was 6,000 years old. Went to an earth science class where I learned that the earth was 4.5 billion years old in ninth grade. And so I was like, well, maybe there's some kind of research out there somewhere that says that the earth is 6,000 years old if
Hmm.
that's what scripture says. So I did research and I found answers in Genesis, ICR, different things like that. And by the end of the semester, I put all my research together and wrote a paper that was 98 pages long and gave it to my teacher in earth science. And so that was the beginning of my interest in creation research. And so I studied it a lot, and I wanted to be a scientist. But after graduating from college, I had a bachelor's in math. Graduated from college, found myself in a situation where I was looking for a job. My wife got laid off. The whole department was laid off,
Wow.
and she was pregnant with her first child. So I kind of got thrust into a situation of I need to have an income
Yeah.
really quickly, and
Wow.
so that was a big thing. But anyway, the Lord provided a job for me, which has been really good and a blessing.
Awesome.
But it wasn't creation research. It
Mm.
wasn't anything like that. And so I said, Lord, how is this something that you really want me to do? Like, is this something that I need to really do? Or have, I was kind of giving up on the dream that I always had because there just did not seem to be a path from here to there. I had a background in math, but nothing else. I mean, not any other discipline, not physics or anything. Then CRS conference came to Liberty. The commute was short enough that I couldn't pass up the opportunity. So the Lord, I felt that
What
He
what
He
year?
was.
What year?
This
The
is this was 2 years ago.
Okay.
So what is it? 2022.
Gotcha.
Yeah, and I felt the Lord say to me that He was excited for me to go to this conference, and it was my birthday's in July. So he said it was a birthday present for me.
Ah.
And so I went to this conference, and obviously I'm loving the idea of hearing all of these researchers present, but I felt God pulling on my heart the whole time.
Wow.
And so after hearing Andy McIntosh talk in the plenary session, um, it was about 10 o'clock at night. I went and sat on the steps and I said, okay, Lord, I feel you pulling on my heart. What do you want me to do?
Mm.
And he said, talk to Mark Horstemeyer. And
Really?
so I had met him before through work. We had developed an engineering course. He used to be the dean of engineering at Liberty. And so I just, like a good introvert, I spent the rest of the conference not talking to him. And then the conference was over. I remember they were packing up the book table. And I was like, wow. And then he came around the corner. I said, well, Lauren, I guess this is my time to talk to him. So I did. So, okay, well, let's get lunch. And so we got lunch. And we were just talking about creation science and whatnot, and that I was interested in it. And he said, okay, I have a PhD that I want you to do, and I have this work called the cosmic fabric model that I want you to work on.
Wow.
And here's all these, he was telling me all about it. I knew nothing about any of this. I had never studied relativity, I'd never studied
Really?
engineering, I'd never studied physics outside of some general physics courses that I had taken in undergrad. And I said, well, I have a background in math, but I don't know anything about engineering or physics or relativity or anything. And so he said, well, that's no problem. I'm an educator, re-educate all day long and teach people engineering, so that's not a problem. But I
Do
said, but I
do
do know math.
do you think he's okay with teaching engineering stuff to others? I'm trying to make a joke on this. It seems like he
The
eats, breathes, dreams engineering, right? Yeah.
Absolutely, that is such an accurate way to put that. But I pulled out a book. Actually, I think have that exact book in my bag right now.
Mm.
It was this book. I pulled out a book and I said, it's in for first steps in differential geometry.
Sounds
I
simple.
said, I love math. So, like, here's a book that I have in my bag right now that I'm reading. And then I said, aha, differential geometry. I remember that's the type of math that they use for relativity. And he
Wow.
said, well, very few people know that.
Wow.
And so
How did you
he,
know
uh,
that?
he was,
How did
because my professor had mentioned it when they wanted to look at the providence of God. So, like, differential geometry is the main math branch of math that you use for relativity. And pretty much that's the only thing that most people use it for.
it's
But I
for
wanted
really?
to take that class in undergrad.
Okay.
And it was a small, like, independent study with 5 students. It's a big deal. It almost didn't happen. He was trying to justify getting the course to up and running
What was the
and
course again?
differential geometry.
Just a course. Okay, in differential geometry. that
Yeah.
Mark was teaching or you were going?
This was undergrad, so this was one of my math professors.
Okay.
But I wanted to take that course. I ended up not being able to take it at the last minute. They practically, I think I was one of the main students that was trying to get into that course
Hmm.
and couldn't take it. But because I didn't take that course after I graduated, I was naturally still interested in differential geometry. So I bought books and started reading it, and now I think I've spent a lot more time on it than I would have if I had just taken the course.
Really? So
Yeah,
if we could get this straight, you must like math enough that on your own time you went and bought a differential geometry book and stayed
I
interested
have.
after cracking that open.
Yeah, I have a lot of books on math. It looks like things like this. You know, that you can't probably see it well on the screen, but it's I'm known for always having some math books in my bag, and that's what I read for leisure.
That's
I
awesome.
don't enjoy things that are um, probably most people enjoy. Like I hate sports. Sorry, I just never enjoyed sports. Hardest class in high school was always PE, but math, I love it.
Man, that's
I
awesome.
absolutely love it.
Isn't it amazing how God makes each of us unique and together we make
That's right.
one tapestry and one body and it's a good so he put you up at a certain corner part of the brain that and
Yeah.
we're life is really boring if we're like if you don't do God's passion it's just totally boring and you know um
Math.
wow that was very interesting I want to ask
One
yeah
more
yeah
detail
yeah
on that too.
please
He said, I really need you to take this course called Continuum Mechanics. It's one of the main courses, and we're not offering it for several more years. And so it actually started yesterday. And so the way we ended the conversation was he said, "Could you start the PhD program yesterday?" And I said, "Well, let me see what I can do." And so that was the start of it.
just to get that clear he said what was the yesterday like you would
The
teach
class had started the day before.
oh okay so you had to be a day
This is
late
like
to
one of my
start
main classes that I had to take.
continuum mechanics that sounds very easy as well um, and then so you needed to get to it and it was basically boom you were if you made the decision you're already going you're already
Yeah.
and you're in the right place you don't even uh have to change where you're at in life you're basically are kind of at the same school or are involved so wow um there's so many neat things there I'd like to continue up on but man um and that answers a bunch of other questions well um so where do we go here okay just continue with that for a moment so you got going on that what year that okay that was 2 years ago 2 years
Mhm.
okay um and when we were talking earlier I really like this comment you had said which was as you've stayed researching this topic you said it was life-giving and
Yeah.
I was so glad to hear that there's sometimes it's going the opposite way in life and you're like okay I'm continuing this program but I just got to finish it and um those were the words you used right and if so what did you mean by that how is it life-giving
Yeah. Um, how do I articulate this? I'm passionate about math.
mm-hmm.
Relativity is fascinating. So on the most surface level, it's beautiful and elegant. Um, it's fun, and you know that's the most surface level. But to go a level deeper than that, I think that it's something that the Lord has put in my path. I think it's a calling that He's put in my life. I know calling is kind of a cliche word that a lot of people use, but I actually felt the Lord tell me several years ago that He had called me to creation research,
Wow
and that's why I was trying to hang on to that word for as long as I could. Um, and then he just dropped all this in my lap. But I think for God to purpose something in your life and then for you to walk in that
Mm-hmm.
is very life giving.
Yeah.
Now, I don't want to oversimplify. I think a lot of people have very, God has purposed even very difficult things in people's lives. In this particular case, this is something that I absolutely love, and I think
Wow.
he's wired me to love it.
Wow.
And so it is very life giving. But then on maybe one level deeper, um, it's the glory of God to hide a thing and the glory of King to
Mm.
search it out. I
Amen.
think just the idea of searching out the mysteries of his creation, it points to the wonder of God himself.
Yeah.
And to the fact that this can be described in this beautiful, elegant mathematical way or modeled in that sense,
Hey.
then just to see it's like math, not a lot of people like math. Not a lot of people like graduate level math or, differential geometry or fun things like that. But to be able to see something that, you know, not many people have seen before. I mean,
Yeah.
there are thousands of
Wow.
physicists out there who've seen all these things in the books that I'm reading. So it's not like a discovery, but it's just the fact that I can read something in a book and about his creation and say, aha, I understand that now.
Wow. Wow.
That's amazing to me
Yeah.
to just see things in his creation that you've never realized before.
Wow. Man. Yeah. Back on real quick on the when you were in was that junior high or high school? The class
Ninth
when you were
grade,
ninth grade. Okay.
high school.
So it was similar experience with me, Mr.
Really?
Randolph or Mr. Jones, but he, uh, in a biology class and, but then moving into a chemistry class and, um, uh, you know, basically we end up having a love-hate relationship. It was almost all love, but we would argue after class, but it was all like, but, I don't know. I had to find certain things and the Lord sent, um, I really want to know what this book was. And I don't remember. But something ultimately tipped me off to the reality of Noah's flood and different stuff that then it was just amazing. Like, oh, there really are answers in scripture really could match this. Um, I came from a Christian background in the church totally, but I was basically on my own seeing these challenges and um but then it was this process of learning more and it's so exciting when you find out there really can be it's almost too good to be true. Like all the world goes against this and there really are if you're willing to go on a different on a path alone, right? If you're willing to
Mhm.
be an outcast, and that's the big thing. Um, if you want the praise of the world, well, you're following the wrong man. You're following the wrong son of man. To follow the Son of God, you have to be willing to not fit in with what the world says, and which one are you going to believe? So, but in that, does he provide answers not to every single thing at every moment, but overall are to remove the challenges and so yeah it was similar with me. um
Hmm.
yeah another thing I liked just that you prayed and God answered. Go talk to Mark Horstmeyer. Did I pronounce the name right? um
Mhm.
and hey, that's when we were talking earlier in our at the conference, I liked one thing you said about that I think you said you and your wife, learned this art of learning that you got to wait. You got to wait. Learn to ask God something and wait.
Right.
And anyways, that was a big example. And well, I don't know if it sounds like it came right away, but um, uh, you know, place it at God's feet and the big thing is if he tells you what to do, are you gonna and that was the another interesting thing we had talked about is if you can decide beforehand that you'll do what he says, that it makes it
Yeah.
like often you were saying he'll answer you quicker, or if you
Yeah.
resolve.
Basically, like if you have what just from my experience, what I have found is that if there's a question that I'm asking him, especially if it's something where I have an opinion about what I want to be the outcome,
Mhm.
if I can say to God first, whatever you tell me you want me to do, my answer is going to be yes.
Mhm.
To say that before you get the answer from him, then he will, in my experience, he will answer it sometimes even quicker, but then you have to follow through, you know?
Yeah.
You give yourself more accountability, but that's what you should do anyway, is to
Yeah.
be obedient to him.
Amen. Well, that is great. So I think we'd already mentioned we're gonna have to do this a few times, and um, I don't know what the minute mark was on this, but how about we jump in? Um, I think you have some things that can begin laying a overview of the cosmic fabric model. Use the word
Yes.
model. So
Mhm.
maybe we just jump in. What is that? Where do you want to go with it? Or if you have screens, what? Yeah. Um.
Yeah, I can share some slides if we want. The basic idea behind the model, at least from my perspective, right? Because really, well, first of all, I want to say a couple of things.
Yeah.
First of all, it's Ticho is really the mastermind behind this, and uh, Mark Wurstemeyer as well. Dr. Tinneb and Dr. Wurstemeyer, they really are the masterminds. I'm at a place where I've been researching it for 2 years. I've maybe just now turned the corner of really
Mhm.
starting to understand this on a deeper level. And so I'm also in the middle of getting my PhD. So I'll explain everything and
Awesome.
the science behind it as best as I understand it. But I'm still in the learning process. So I
That's
might
awesome.
misspeak or something, but I will articulate the best of my ability. But I think foundationally, at least from my perspective, the foundational idea is this that the universe was created by God, right? He is an intelligent person being, right? So he's God.
Yeah.
He is a person, and there's a creative aspect of that. So one famous engineer, von Karman, is famous for a quote saying something along the lines of physicists study what is, and engineers create what never was. So his point
Can
there
you say that
is that
again?
he's
Say it again.
engineer. I might be misquoting here, but if I can remember it well, engineer or physicists study what
What
is.
is
Engineers create what never was.
okay?
The
So
emphasis there is
practical,
that
like doing.
it is. I mean, really, engineering is an application of physics.
Wow.
It's a subset and application of physics.
Wow.
And so the emphasis here is that maybe it isn't proper to call it a subset in the sense that there is a creative component
Mhm.
that goes into engineering. You're creating something, right? There's design that's built into it. And so then maybe I'll go back on my statement a minute ago. Maybe it is a subset because the point that we're making with the cosmic fabric model is that there is design in the physics that God created as well. And so when I look at the universe, um, functional structure implies design. So there is design that God created in the universe.
Wow.
And because of that, it's not inappropriate for us to approach a topic like astronomy or astrophysics from an engineering perspective. I know that those are two things that you wouldn't ordinarily put together automatically, but if God is the creator and he created the universe, then literally the universe was engineered. Or
Wow.
Dr. Verstemeyer has coined a phrase, creationeering.
Mm.
So the universe was creationeered, if you will. But with that, anyway, I guess I'm going too long here, but with that, principles of engineering that we use to study that field are appropriate, can be appropriately applied to understanding the cosmos. That was the foundational idea that this came from. And so fundamentally, what we're saying in this model is that we are comparing continuum mechanics to general relativity. And actually, the cosmic fabric model took continuum mechanics, applied it to space-time, and what just fell out of it was the equations of general relativity,
Can you say
which
that
is
sentence again?
amazing.
It took the what and the what?
Yeah.
Say that again.
So the cosmic fabric model took continuum mechanics,
Okay.
which is like a piece of metal or wood or material of some sort, or what kind of mechanics can you do to it using calculus?
Was that
Applied that to space-time.
the same as I was reading just a bit of the paper structural mechan what was the word they were using? Was it structural?
So continuum mechanics is basically the continuum part, just means that you can do calculus on it.
Okay.
So it's the mechanics that you would do with calculus, essentially.
Cool.
Take that, apply it to space-time, and what fell out of it was the equations of general relativity.
Wow.
And so Dr. Tenev's PhD thesis and the various papers that he published with Dr. Horstmeyer, they outline those exact concepts in detail,
Wow.
which is fantastic. And so it takes continuum mechanics, compares it to general relativity. It takes material science and compares it to astrophysics, fundamentally.
How fascinating is it that the most basic, you'd think, empty thing, and there's whole. I hope we're gonna have a lot of good talks on this. You know, what is space? What is, but you'd think the most simple, basic, empty thing of all, space. And what you're saying is there's design there, and it would really be the foundational design that makes every other design possible. Like in the same way you have DNA and everything in the cell that makes, comes together, that makes possible all the amazing biological designs. But of course, all the way down to the most fundamental aspect of the physical creation is, okay, they usually say fields, although they say space-time. So there's this whole talk, is it appropriate to talk about a hyperplane? What was the word, hyperplane or hyperspace? Yeah. So without totally jumping right in that, but the claim here, ladies and gentlemen, is that there is incredible design and engineering at the most fundamental level of physical existence, like space itself. Now that's interesting. That is fascinating. And even if most of the math here then, goes over a lot of our heads, we should be interested in this. And actually, before we go on, this is one question I did have. Do you have, Cameron, do you have one of the a visualization, when I think of these mysterious questions of space and space-time or cosmic fabric, a visual that I always think of is being, if you're in a boat on a lake, and the closer, like in a kayak, the closer you get to the level of the water, the surface, you see the waves coming. Now I know that's a liquid, and now it was as opposed to a solid, and hopefully we'll get into some of those things. But although it was interesting reading a bit of Ticho's, just the very beginning of the paper, that some of the early ideas, they were visualizing as a liquid as opposed to what the ether was, at least original ideas of ether. So I didn't know that. So I'm tickled that I don't know, just seeing and again, I know there are different kinds of waves, pressure waves against whatever, but I always just, it's this 3D body of water, and I think as an analogy of this blue water of what is space itself that makes everything possible. And there's just something beautiful and glorious about that. So my question was, do you ever have a way that to visualize these things that comes to you? And maybe the answer is no, but for me, it's been like a lake of water, and it makes me think on this different plane of what space is. But what about you?
Yeah. Yeah, a lot of people think about ripples in water and things like that. From looking a little bit into mechanics, I think I probably used to think of it more in that terms. With water, it's a surface wave, which is a little bit different than the shear waves that we talk about in this model. But when I think of it is, I usually visualize a sheet of elastic metal, some sort of an elastic large sheet of metal, and use it to, or sometimes I think of it as more, visualize it more like a rubber sheet, which is what probably more people commonly do. And, I think we've all seen the images of sort of a rubber sheet with a heavy ball that's placed on it. There are definitely a couple of ways that image breaks down.
Right.
Why does the ball sink down? Because gravity's pulling it down, but that doesn't translate. But there are some things that I can explain a little bit about just regular general relativity that do this. But the point is that there's curvature right? So the point is that there's deformation that's taking place on this hyperplane or this hyperplate or the sheet, if we will. And that deformation creates a geometry that is very important with understanding relativity and general relativity specifically, because that geometry, there's a mathematical concept called geodesics, which is a generalization of a straight line that actually is curved. And that geometry plays a huge role in understanding general relativity.
Wow.
So this model takes what conventional relativistic physics sees as an abstraction of an abstraction of an abstraction, and it actually demystifies it a little bit. This model, if this is, a model is always describing something, not the thing itself, right? But if this model is accurate in what it's trying to describe, it actually effectively demystifies several aspects of general relativity, in my opinion, because it makes it more concrete and more intuitive with our understanding. I mentioned functional structure implies design with the universe. One of the things that you'll notice, and it was actually Dr. Tanev that pointed this out to me, is that everything on the earth, man was given dominion over, but the cosmos, man was not given dominion over that.
Right.
So what I think is the functional design and structure of the universe is observability. Because when we observe the universe, then it points us to the magnitude of God, to the infinity of God. There's a great book out there called The Privileged Planet. I have it on my bookcase here that goes into great detail about the observability of the universe. But I think that there's so many things about the cosmos that are well designed for observation, and I think that observation primes our hearts to realize how big of a God we're dealing with.
Wow. Man, that's awesome. And it says he's enthroned. Heaven is my heaven is my throne and earth is my footstool. I about butchered that. Everything you could call heaven, which in my view, Hebraically, there's not this clean separation between the physical and supernatural. It's just kind of intermixed. I'm not saying there's not a difference, but when it's, Isaiah 66:1, heaven is my throne, earth is my footstool. And then what does he say? What place then can you make for me? But on this one, I will look on him who is humble and lowly and who trembles at my word. Am I mixing? I might be mixing resources.
So Isaiah 61?
66 verse 1 is the last chapter.
66 verse 1. Yeah. It's cool. Yeah, I love that verse.
So many other things, other scriptures associate God is enthroned in the heavens. And so I think there's a connection there. The overall space time and the overall heavens. I know then there's a physical heavens and there's something beyond it, but that's going beyond just our man, the realm man was put in charge of. And so what? Yeah, and it's telling of the glory of God. Psalm 19. So, yeah, that's good.
Yeah.
So,
do you want me to unpack a little bit about what the model actually is?
Let's do it. Yeah. So what
the
model is?
Let me try to say this as succinctly as I can. And if you want
to share your screen with that, as soon as you have something, go ahead as well.
Yes, I can do that. Let's see how this goes. Yeah, 1 second. See if this works. You see it? Do you see my screen?
It's black right now. Can you try to?
Okay.
But let me hold on. Let me try to do a little
or I can just talk.
Let's not give up quite yet. Let's see. We had that one. We have a bunch of screens now. We worked forever to get this thing to work, so it better work. Oh man.
Well, I'll let you look at it, but I'll still talk for a little bit. So basically, the idea is that the universe is composed of this ether, right? So, and ether is a view that the universe, empty space, if you will, is not actually empty. It's I don't think of it in terms of regular particles like we're used to thinking about, but that space itself is a material. It's a material that we see through, we move through. So our existence is living this material. The material is not just out in space. The material is all around us. But potentially, maybe matter as we know it is composed of this material or behavior of the material. And the material does respond to matter, though, which is interesting. Now, this model has the ether as being extremely dense, on the order of 10 to the 96 kilograms per meter squared. Extremely stiff.
Can you say that again? How the number you just gave was what?
10 to the 96 to the power of 96. So that's a really big number.
To the 96, what unit of what?
Kilograms per meter squared.
So
that's a pretty even dense.
Okay.
It takes a galaxy to really bend this thing.
Wow.
Extremely stiff, 10 to the 113th newtons per meter squared, and extremely thin, postulated to be in the order of Planck's length, 10 to the negative 35 meters. So pretty extreme.
Right.
But what I just am describing is a plate, like a sheet, or a plate. Now, obviously, we live in 3 dimensions, so this is actually a 4-dimensional hyperplate. I say hyperplate because we live in 3 dimensions, but it still behaves as if it's a 4th dimension. Maybe it's 4 physical dimensions, I don't know. Or maybe the curvature is just intrinsic curvature that's non-physical. But I think that it would have to be.
Do you want to unshare? Because I think that's not, at least we'll get your face back.
So, all right, can you see my face?
Not yet.
Oh, man. Should be there. You might be better off without my face, actually.
No, we want your face. Let's see. Boom, no, boom. Oh, come on, teams, be happy with us. Oh, we lost it.
Teams loves me. Apparently it hates you.
Today it does. Oh man. Wait. Was that no? Window application. No. What here? Hey, keep talking. I'll keep
going.
I'll keep playing with this.
I'll keep going. I'll do the elevator music. So obviously we live in three dimensions. So we're talking about when we say that it's thin, this plate is thin on the order of perhaps Planck's length as a postulated example, then we're talking about thin in the fourth dimension. But non-vanishingly so. Can't be zero because you have to have mechanics associated with bending. Um, but anyway, it's an ether modal, and the idea is that it's a material. And so we would expect to have things like, that there are certain things that we can know from material science. Perhaps these insights that we have from well-established things in material science can provide some insights into astrophysical anomalies, and that's part of the idea as well. So basically, continuum mechanics applied to space-time, general relativity falls out of it. The regular equations of general relativity were derived from continuum mechanics. Again, you wouldn't expect those to go together, but it literally came from a standpoint of mechanics of materials.
Hey, real quick, I finally got you back, but you want to try the share one more time?
Let's see.
Okay, drum roll, ladies and gentlemen.
Drum roll.
Oh, it's black screen again. Okay, that's not for some reason working. Sadly, cry. But
I'll go back.
So back to unshare that.
Yep, I'm back.
There it goes. Okay. Too bad, so sad. Okay.
All right. So, and then material science relates to astrophysics, which I can go into a little bit. But let's see, what else was I going to say about that?
On these numbers, that's one thing that it boggles the mind, but someone might use those numbers as something, to say something's wrong here. And I don't have ready at hand, but I've seen other figures before that dealt with, there's certain quantum mechanics figures dealing with space-time or whatever that's not just like your model or something that they're probably the same thing basically, that also have numbers that are like, it seems wrong, like that can't be right. Do you know what I'm talking about? Do you have any examples that could answer that objection? Like if for instance, if you have something that says almost an infinity of weight or something like per square inch, you think, how could that even be possible? But there are other things. If you accept standard, cause not just cosmology, standard physics. What's a standard model of quantum mechanics, stuff like that? Does anything come to mind, Cameron?
So I need to specifically say, as a PhD student, quantum mechanics is next summer.
Gotcha. Okay.
but from what I have read in Dr. Tinn's papers, actually, I forget what quantity it was. One of those three quantities that I just read to you, not Planck's length, but one of the other two, either the density or the stiffness of the fabric, is actually in agreement with a number produced from quantum mechanics to an order of magnitude. So, maybe it was density. I think I can't remember which one it was, but within an order of magnitude. So we're talking about 95 zeros, or whatever it was, 95, 96 zeros, and so it was agreement. In agreement
per square or cubic something.
Right. Yeah.
It's in agreement
it was actually in agreement. But I would say, like I was alluding to earlier, there's physical realities, right? But then there are mathematical models that are designed to describe those. I can describe the Earth as a sphere, but we all know that it's not really a sphere. It has all kinds of topology associated with it. And so any model that we create is going to be a simplification or an approximation. And our models are accurate to the extent that they accurately describe what the physical reality is. When you get into things that are very difficult to directly observe,
Mhm.
which is true of quantum mechanics and to some extent relativity, especially in astrophysics, there's a lot we can't observe directly. Then you just have to make models that are the best that can be with what we have. And so we have to understand that when two models disagree with one another, it doesn't necessarily mean that one is wrong. They probably both are wrong,
Right.
but it's just to what extent and for what reason. Right.
Yeah. 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 That's great. Um.
One theory can't disprove another theory
Yeah.
in the sense of proving, right? There's very little in life that we can really prove. We can have very viable theories.
So the fascinating thing about this model, and you're continuing on it, is the claim is, and you were saying it. This really demystifies, simplifies general relativity or relativity in general. I don't relativity in general.
Like we're there.
That was an accident, but hey, I'll claim it. It demystifies. For me, here. So many 20 years ago, I got this book. You know, so I've always been
Mm-hmm.
fascinated in this thing. I'm like, okay, how could I understand it just visually? In these matters, and but since what Russ Humphreys did, and understanding relativity as a simple fabric model, it demystifies for me why time slows down, why it's just
Oh,
it's
man.
it's just a matter of, it's just simple physics. Like we're physically waves on, in a fabric, and so if this fabric gets um stretched or decompressed, I don't know what, that itself causes different uh
Yep.
light flows through this fabric, or maybe that's not quite right to say it, but the change of of time flow and different stuff, it's just, you just physically understand it. It's not philosophical like craziness. It's just a physical um uh
It's pretty
light.
philosophically crazy.
Yeah.
Special relativity is. And
So
then you get into general, yeah.
in
But
in,
I
in
see your
this
point though.
model,
It's
it sounds like it takes us further to say, you guys understand, this advanced materials science understands on a mathematical way of analyzing materials, pressure, and I don't know, all the things you could materially
mechanics.
understand, mechanics. I don't spend my time in that, but I believe it. It's like, okay, yeah, there's 100 different ways to do shear stresses, this, and you can put equations to it. It sounds like you apply this simple, okay, they're not so simple, but it's just straightforward materials analysis of conditions,
Mm-hmm.
understanding space as a, whether you call it visualize it as, but it's a solid he was using the word hyperbole. It's a fabric, it's a material. And wasn't the claim that applying basic material science almost like rigorously to general relativity, and they match the
Continuum mechanics, right?
con- continuum mechanics. So um yeah, take it from there. I mean, is that true? And I mean, that would be amazing to in a very rigorous mathematical way really prove how relativity works. And um yeah.
Yep. So, um, anybody interested in math, I advise them to take a look at Dr. Chenev's PhD thesis, and they'll see it in full detail. I'll highlight a couple of concepts that I think maybe illustrate what you're pointing on here. One is Hooke's law. So Hooke's law is in the simplest form F equals kx. So force. Think about a weight oscillating on a spring, right? So you have a spring that's here, and it's oscillating because you have a weight on it. Why does it oscillate, right? So it's moving up and down, it's accelerating, so you have to have a force that's accelerating that thing. And it's oscillating because there's a force, and that force is equal to a constant times x, which is the displacement, right? And so that changes as the spring oscillates and things like that. That concept can be generalized in all kinds of different ways. And so in mechanics of materials, one of the things we talk about is constitutive relationships, where we have that strain is equal to stress times a constant, and that's related to the material properties that is there. So there's a stress and strain material relationship. The important thing there is that strain is Vx, it's the physical displacement, right? And stress is like a force term, right? It's related to force. And so that's a really, really important property of engineering and material science, because it's relating the geometry of the material with the forces that are within it.
What was the key word? The very important word was what?
Just the stress strain relationship.
Stress strain relationship is a, say it again, is a,
it connects the geometry to the forces and stresses that are within the material. And if I have something and I put a lot of force on the edges and it deforms, I'm changing the geometry of it.
Okay. Is that related to Hooke's law stuff and the springs?
Yes, it is, because Hooke's law in its most general form is relating that displacement with the force that's associated with that. And so when you are deforming material by, for example, compressing it, you're applying a force, and that's causing a geometric change. You can also have changes in geometry that cause forces. It's essentially building an equivalence up to some constant. When I say constant, you can break it out to be a tensor, but it's related to the material properties, modulus associated with the material properties. So when we're talking about general relativity, let's go back to that rubber sheet with a ball on it, and it's deforming around it. So we have a geometry here, right? So if you picture a planet sitting on top of a sheet that's sort of floating around in that picture that everybody's familiar with, there's a geometry there. There's a deformation that's taking place. So basically what's happening there is matter causes strain in the fabric, and that would be the cosmic fabric model's interpretation of gravitational potential. You put matter like a planet into the fabric, and the fabric strains. It bends around the presence of this matter. That is Hooke's law in a sense, because where that's an insight in the cosmic fabric model offers to this, that the change in geometry creates a strain in the fabric. And so or stress in the fabric.
When you say the change in geometry creates a strain in the fabric, when you said change in geometry, you're referring to just where you're at in the space-time, or what do you mean change?
So picture a rubber sheet and it's just pulled tight.
Okay.
Now picture a heavy ball that's put on it, and it has a change in geometry. Okay. That heavy ball is the presence of matter, and general relativity says that wherever matter is, space-time begins curving around it in response to the presence of matter. I did misspeak. I said strain. I should have said stress earlier. So the geometry is the strain. Okay. Right? So that what I'm saying here is that change of shape that's taking place with the fabric and the presence of matter, that straining that's taking place is a geometry. That geometry, the cosmic fabric model's insight, is that geometry is related to the stress state of the fabric, thinking of the fabric as being like an ethereal material. Mm-hmm. And there's all kinds of different insights that I think can come from looking at that like a material. So let me give an example. You were talking about light a minute ago. Mm-hmm. Light, one of the amazing things about special relativity is that the speed of light is invariant,
Mm.
right? So that there's two postulates that Einstein created with special relativity. One, that all the physical laws happen the same regardless of what inertial frame you're in. That's essentially a concept that Galileo introduced, or a version of it. But then his second postulate is that the speed of light is invariant for all inertial observers. And so what that means is that you would expect that if a person is standing stationary and they turn on a light, it's going to go out at a certain finite speed, right? But you would expect that if somebody was moving really quickly and they turn on a light, that somebody who's, you know, the person's coming towards them, that they would see it, um, at a different,
Yeah.
at a certain rate. This person went, there would be a sort of a Doppler effect going on. In fact, the speed of light, moves, or I guess what you would expect is that you would move faster because this other person is moving, but it doesn't. It moves at the same speed no matter what. There are a lot of things that relativity says this is just how it is. This is just an observation. This is just what it is.
Yeah.
The cosmic fabric model offers some explanations for why. So why is the speed of light invariant regardless of the motion of an observer? And essentially, it's looking at things like the material properties of this ether, right? So if we suppose that there is an ether and that it is some sort of a non-baryonic material, so it's not the type of matter that we're familiar with, I don't think it is, but some sort of material, then its behavior is, you can think of light. Think of, for example, a gravitational wave. So if I just hit a metal sheet, there's going to be waves that go out, right? And so there's an analog to that in the cosmic fabric model. It's essentially a gravitational wave. You have this deformation that's taking place. There's an elastic wave that goes out throughout the material radially. And so that's essentially what we're talking about with the gravitational wave. If you have, this is a shear wave, right? So there's no compression waves in this model. So there's a shear wave that's taking place. The equation in mechanics for a shear wave is that the velocity of that wave is going to be the square root of, let's see if I invert these, I think it's density over the elastic modulus, or the shear modulus. And so density over shear modulus, maybe I have those two backwards, but I think that's right. Take the square root. That's the maximum speed of a shear wave. Well, that speed in this model is c. It's the speed of light. And well, gravitational waves do travel at the speed of light. So there's a maximum speed that light is able to travel in the fabric. And you can slow it down when you do different things, right? But anyway, I just think it's fascinating that this model has the ability to explain sort of a why with what we're seeing in terms of the speed of light, why it's invariant for different users, and the fact that
and it's not some minor, like, invariance is core to special relativity. This is at the heart of the strangeness of it, right? I mean, that's not some minor thing to explain.
Yeah, it's at the core of the weirdness associated with special relativity, but it offers, looking at it from a material standpoint, it offers an explanation of why, because there's a limit to how fast a wave can travel across the material. Right.
And if you're thinking of it as a material, this explains just simply materially why. Because this invisible space is actually material, and it has a limited speed.
There's a rate at which matter-to-matter interactions can take place. And so it's even more subtle or more general than just the speed of light. We're limiting the rate at which matter-to-matter interactions can take place. Now, suppose that you deform the sheet. It's an elastic sheet. You do an elastic deformation on it. That's going to change the properties of the sheet. It's going to change how fast the wave can vary. But here's the deal. if you are changing the rate at which two particles of matter can interact with one another with this straining that's taking place on the sheet, what does that mean? It literally means that you're slowing down time.
Say the
If
first sentence again.
particles,
If you could slow down, say that again. If you,
so if you have strain, we're pulling this sheet, we're doing a deformation on it, where there's an elastic stretching that's taking place. That's going to make the interaction between particles slower. Okay. Well, if the interaction between all particles in the space-time continuum within certain, within some gravitational potential, remember, strain corresponds to gravitational potential. So I'm at a gravitational well, then these interactions are going to take place slower. And what that means is that, I heard people say in the past, can you imagine what it would be like if time slowed down and everything you looked around and everything around you was going slow? I remember being in high school and saying that's a dumb idea, because if time was going slower, my brain, the particles in my brain, the interactions in my brain would be firing slower too. The clock on the wall would be going slower. If time slowed down, I would never observe it.
you wouldn't know.
I would never know, right? But what we see in general relativity is that a observer at a distance where time is not moving slower can observe time slowing down. And so locally, you would not, right? And that's why, according to general relativity, the local observer always sees the speed of light as invariant. Well, of course they do, because the rate of particle or matter-to-matter interactions is slowing down proportional to this strain that's taking place in the fabric itself. So it just adds, from a material science, an answer to why, for some of these abstract concepts, that special relativity and general relativity just says it is.
Yeah. And probably the worst is, how can you affect time? I mean, that's so philosophical, crazy.
These really interesting things with that.
To say, I don't have to think philosophically. Time, I can see something outside of time, outside of this physical plane, like God, or a alien he put outside of it. There's a more general, I don't even know what to call it, something that could be living outside of this fabric, would have a different time zone or something. So the weird stuff that happens with relativity and time warping, to me, is just because we're limited by this fabric we're in. And so I feel like people who don't understand that, it's just simple, but I'm not understanding the equation level. But would you say, Cameron, without a fabric model, though, uh, people are just thinking of fields and stuff. Are they missing something? Like, they don't have the advantage of what to demystify this? Like, what don't they have that?
In the creation community, you're asking me a highly volatile question here. Very hotly highly contentious topic. So I'll try it lightly here, but yeah, I do. I do conjecture the existence of a real physical ether, and so I do see it in those terms. I know that there are many people. I think Phil Dennis may be one of the folks who's very convinced that there is not an ether,
Right.
and that there are, I want to try to articulate is used for them, but I think maybe quantum fields and different things like that. So there's this concept that is the popular concept in physics right now, that there is not a material or an ether out there, but instead there are fields. And so there's not that there's something there, but it's that when you put something there, it behaves in some predictable way. And that's modeled by the mathematics. Personally, I feel like, for example, when you talk about something like a gravitational wave, I know this was also a recent discussion amongst a lot of folks, but something like a gravitational wave, you're saying that there's something waving. Well, people say, well, the field is waving. Well, okay, but how does the field wave? What is the field? And if the field is waving, then how can it wave without being something physical?
Hmm.
And again, I think folks can probably say, well, there's not a waving happening until you put something there. But then how does the something there know what happened at another place in the
Yeah.
cosmos at another
Yeah.
time and then react to that? Maybe there's a very, I'm sure that there are very intelligible explanations for that. I don't have the answer to that question. I have an opinion on it, but I'm also a student, and so I temper my opinion to say that I haven't fully earned the credentials of some of the folks who hold a different opinion or even the same opinion. So I'll give you my thoughts on it now, but I do think in terms of an ether, and it
Yeah.
does make sense to me and sound intuitive.
Yeah. Well,
It's a debated issue.
yeah. Um, so we have so much more to talk about, but do we have anything else to close out this um uh uh general overview? And if it's cool with you, I think we need to dig in further on some other times. But do you got another thing or two to summarize stuff right now, or what do you think?
Yeah, I mean, I think I don't know. I think the biggest thing in my mind is just that um, this model, like we were talking about earlier, comes from the perspective that the universe was creationeered. It was
Yeah.
designed by a creator. We don't have dominion over it,
Yeah.
but I think it's built with observability in mind.
That's awesome.
And so, for example, there's a lot of things about astrophysics, yeah, or I guess I should say there's a lot of things about astronomy that we don't know. There's so, when we,
Yeah.
when we talk about observing a distant star, we can't actually even resolve the diameter of many of these stars. We have to just look at a point of light
Wow.
that's basically a static point of light and decompose as much information from it as we can. It's surprising how much we can get. But there are so many assumptions we have to make when we're observing the cosmos.
Wow.
Galaxies, we can resolve those. Obviously, we've all seen pictures of galaxies. They're really big. But I think if this model is an accurate representation of God's creation for what it's setting out to accomplish, then there's something powerful here, which is that what we can do, I can't take a galaxy and put it in a laboratory and do things to it and see how it behaves. What I can do is take a material, right? And we haven't talked about sort of an idea I have called cosmic grains, but
Mm.
um, it's essentially relating material science to understanding some anomalies within astrophysics. But what I can do is I can take a material and I can put it in a laboratory and understand how it behaves.
Interesting.
And so this model offers the prospect of unpacking even more observability. We were talking earlier about how potentially demystify some of the aspects of general relativity. That's great. And it's okay for relativity to be mystified if this model is wrong. But I think it's a powerful thing to be able to understand how material works in a laboratory and study it to the nth degree, but then to potentially be able to leverage that to have deeper understanding of how large, for example, the large scale structure of the universe um, is behaving. Dark matter is a concept that the cosmic fabric offers a very simple solution to. So there are insights that I think we might be able to gain from creation if indeed this is an accurate modeling of God's creation.
Absolutely. Yeah, I saw a little bit about uh Tico's um material about dark matter in his thesis. I mean, just like in the headings, and I thought, why isn't this being talked about more in our little community and more um so man, I know we've only
Most
barely.
people in the creation community only know about his creation time coordinates paper that he
Yeah.
wrote for ICC in 2000, I think it was 18. But that was really a side project for the
Yeah.
creation of
Yep.
the cosmic fabric model. So it has there's a lot here.
Yeah. And you just said the word I hadn't heard, this cosmic grains, but
Yeah,
you just piqued my interest in that, but that probably opens a whole can of things.
it's a paper I hope to publish in the future. But the
Okay.
basic idea is that um, it's looking at how a material behaves or how a material is composed and what structure it has, what substructure it has, and comparing that to the structure of the universe. And there are some interesting parallels that are things that you would predict and expect to see.
Mm.
Um, that again, we might be able to look at a material in a lab and see how it's structured and see how it operates and behaves, and then see something very similar in the cosmos.
Mm.
And if I can get to a point where I have mathematically modeled this out, and really put some flesh in the bones, so to speak, is sort of a qualitative idea at this point, but then I can publish a paper on it. But the idea is that that may be able to provide some insights into what we see in the cosmos
Awesome.
because of that exact idea we were just talking about.
Man. Yeah, he made he wants, I think God wants us to discover these things. Um but he does hide them, and I feel like um whenever there's a simplicity to an amazingness, but also a simplicity to uh many of the wonders that we've discovered in science and stuff. There's just a simplicity. E equals mc squared. I mean, how can that be so simple? I know not all the equations are that simple, but there's still just this. It amazes me that at least conceptually, a lot of the things end up being really, if you could visually see it, being really easy to understand. And I don't know, maybe that has to do with some of these things, like uh, material science allowing us to see how this invisible space that God made, how it actually works. That the equations can end up, I don't know, helping us understand some of these things. But
Well, that plays right into, what I was talking about with observability because
mm,
I was studying stars and the structure of stars, stellar evolution, stellar interiors, and different things like that. And I realized, again, these are models, right? Not the physical thing, but stars are. I'm realizing they're really, really simple things. It's
yeah,
a ball of burning gas, you know.
yeah,
Yes, it has convections and different things that are going on inside of it, and it's non-trivial, but they're really simple. I study things like relativity, and I see E equals mc squared, which it is more complicated than that. That's a very specific case with the Einstein field equations and whatnot, but or with the stress energy tensor more specifically. But these are very simple things that you can write down in a formula. And I
wow,
have a wallpaper in my computer that has the Einstein field equations on it. There's the governing equations for the whole universe,
wow,
and on my screen right there in one equation. But the thing is, these are so simple. If you want to study something that's really complicated, look at a cell. We're talking about the psychology of a human, right? Those things are immaculately complex.
wow,
And to me, we look at the vastness of the cosmos and we study really complicated, counterintuitive concepts like relativity, and we realize that it's actually the simplest of all cases, and that the things that are the most complex are the things that are in front of us all the time. It Two things about that. One is it speaks to the incredible depth of God's design
wow,
in the world. And two, the simplicity of what we see in the cosmos again plays into our observability of it, that we can even grapple with our minds the concepts that we're seeing in the cosmos, and to be able to write it down in a single equation helps us to study it in various different ways. And so I know that real life, the closer you get, the more complex it's always going to be. But
Right.
the universe was designed to be observed so that we can behold the greatness of God.
Amen. Well, that's a perfect ending point, and I hope we can dig further later, and we're gonna have to get the screens working, so you can share your screen. But we'll figure that out later, God willing. And yeah, thank you, Cameron. That was awesome, man.
Thank you. Thank you.
Yeah. Okay. Well, see you guys.